All right, so welcome. Today we're going to talk about application security and sort of the Solution Street best practices around that. Our agenda for today is first to talk about why do we care about security? Why is it important? And we're going to talk about what are the threats out there and secrets to address those threats. We're going to boil it down to kind of 10. There's probably more than that, but this is the kind of primary 10 I'm going to go through today. And then we're going to talk a little bit about process and policy and how we can use that to be more secure. And then we'll summarize everything and allow for a final Q&A at the end. But again, as I said earlier, please do not hesitate to jump in and ask questions as we go. So why is application security important? Probably many of you remember a few years back when Equifax got hacked. They lost hundreds of millions of records. And it was a pretty significant event, pretty big embarrassment for them, and a huge cost. Right now the last stats they have are over $1.4 billion to recover from that hack. And the initial entry of that hack was caused by a vulnerability with the Apache Struts framework, which is, for those of you not in the Java world, it's an MVC-like framework. That hack was disclosed and not patched right away by Equifax, and they got hacked. And so this is obviously one of the bigger ones that we've seen, but we don't want any of our customers to sort of suffer this, especially at our doing. So we want to make sure we're doing everything we can to prevent an event like this. But we just definitely don't want any of our customers to have to go through this. So about 17 years ago, a couple of friends of mine, Karthik and Selva, we presented you've been hacked 10 secrets to protecting your Java enterprise apps at a Java 1 conference, this was back in 2004. And so a lot of the content that I got today is stolen from that original slide, the original slide deck that we did back then. It was really popular attendance to it, and we got a lot out of it. So a lot of this stuff comes from that. So I just want to give credit to that. So the first threat we're going to talk about is profiling. So profiling is sort of the hackers looking at what you're running and trying to figure out information about your systems, your applications from the outside, and they're going to use that to hack you. So a couple of the primary profiling tools they use. First is HTTP headers. So when you are talking to any web page on the internet, if you're getting a web page, if you're signing into an app, the protocol underneath the covers is HTTP. And as part of that protocol, there are headers, and these headers contain information. And one of the pieces of information that the server can provide when you send a request to it is information about the server. This was intended to sort of let folks decide on the client and server how to talk to each other best, but unfortunately you can give out critical information. So in this case, it's giving out Apache 2.4.6, and it's giving out the operating system CentOS that it's running. So both of these pieces of information could be used by a hacker to say, well, let's see, are there any known vulnerabilities to Apache 2.4.6? If there are, let's go ahead and run that script to try to attack them. Same thing with the operating system. Now I know that they're running CentOS. I don't know what version of CentOS, thank goodness, but at least kind of gives the attacker a little bit more profile. Going down below, some people like to put HTML comments in, which is a good development practice, but it can give away information about the system. So in this case, we know who the author is. We know that they have a MySQL database. We know they have a bug, and maybe I could go look at Stack Overflow postings by Joe Smith and learn more about your app and put 2 and 2 together and kind of get even a bigger picture. So if I know that Joe's working on this app right now or recently, I can sort of Google questions Joe's had and really kind of get a full picture. So that's the first threat, profiling. So the secret to dealing with profiling is don't give out any information you don't have to. So remove all your comments from your HTML and JavaScript. there are tools out there that can strip those out before they go to production. A lot of this information could be stored in your version control system, so it might not be necessary to put it in the code. If it's server-side code that's never going to get sent to the customer, then it would be easier to put comments in there. And then at this HTTP server, at your web server level, there are settings that you can do to disable giving out that much information, or you can give out a much more generic version of the information. And then a lot of people have debugging and other backdoors in their dev and test servers. We need to make sure that those are locked down before they go out to prod. Sometimes it'll say, when the deployment was, what version it was, all that kind of stuff. We want to make sure that that's not available. Make sense? Anybody have any questions on profiling? Okay. Let's talk about threat 2. Threat 2 is exploiting improper error handling. So I'm sure most of you have been using a web application probably on a Sunday morning or a Saturday night, and you've gotten this kind of exception where you see all this code in your web page. This is a result of developers not handling their exceptions, and some exceptions getting created and it's getting propagated all the way back to the web page. This is really great when you're in development because it helps for debugging purposes. You don't have to go chase down the log files. You can see right away what happened and go solve the problem. But in production, it's giving out critical information about the app, file names, directory structures, code versions, all sorts of third parties that you use. So it's very dangerous. And so the secret here is fail safely, right? So expect the unexpected, handle all your exceptions. No matter what language or framework you're in, there's some top level configuration or setting that says don't propagate exceptions back to the web page. Just get a catch-all, show a generic call customer service type page when that happens. So that way, it could be a real issue, could be a fake issue, but either way, you're not giving that information back to the end user. Make sense? All right. So threat number 3 is malicious input data. So in this case, a hacker passes bad get request data, post request data, bad headers, and they're looking to see stuff they shouldn't, break the app, make the app slow down, find out more about the app, or even in some cases, execute a script on their behalf. So we're going to go through a few of these. Parameter tampering. So in this example, I'm supposed to view account 62165. That's my account. So the URL has that parameter with that value in it. The hacker just goes in and changes that ID to a different account number. Maybe they try a bunch of them and hope to guess a correct account number. So they, in a terrible case, they'd be able to see someone else's account. So maybe I'm logged into my bank. Everyone has an account at Bank of America or whatever bank it is. They log in and then they just try to see other people's accounts. The other thing they do is manipulate hidden form fields. So a lot of times if we're building a multi-page transaction, we'll use the data from page 1 and stick it into hidden fields in page 2, and then we'll use those hidden fields to submit to the server. Well, in this case, maybe the price of an item was $99.95. I can just go in and change it to $1, and then when that gets submitted out, I'm only charged $1 for the purchase. Buffer overflow is another type. In this case, you're pushing more data into an app than it expects, and maybe getting access to memory in the operating system that you shouldn't have, maybe even getting the ability to execute an app that you shouldn't have. These types of attacks are really tough from the outside, but they are indeed possible. And then the last one is just like adding your own parameters. So I'm going to this web page, but hey, I'm just going to go ahead and set the balance to $1 million by adding in my own parameter at the end of the URL. So the secret of dealing with all this is really just doing a great job at practicing input validation. So making sure you know all the ways that data can get into your system and validating it for correctness, format, length, range, context. Don't assume the data that comes from the client will be legitimate and good. Don't rely on client-side validation. A lot of times we're building JavaScript front ends nowadays, and we're doing validation there, and then we just send it over to the server and assume that it's in great shape. We can't make that assumption, right? We have to assume that the hackers, could have manipulated that data before it came in. So all modern server-side frameworks have some sort of either programmatic or declarative validation or a combination of the two. In this example, this is a Ruby on Rails declarative validation that's allowing you to, check to make sure the first name's there and it's within a certain size. It's checking the email using a regular expression. Rails also does a good job at using a hash map of permitted variables. So you can't just add any variable and send it through. Rails says, we're only going to accept this set of variables. It can make development a little more painful, but it's much better in terms of the protection of invalid data coming in on the wire. Any questions on input validation? Okay. So the fourth threat is code injection. So in this case, the hacker is passing somehow, maybe using the previous threat or maybe some other way, code into your app, and they're attempting to get you to execute something you don't want to, whether it be SQL or stealth commanding or cross-site scripting. But these are different problems that can happen. So let's go through a few of those. So Sql injection is where you pass in a parameter that modifies a SQL statement. So maybe I have a user and password login screen, and instead of just putting in my username, Fred, I put in, tick space or 1 equal 1 and then dash dash. And what happens is if the person is using dynamic SQL, it gets back all the users because the or 1 equals 1 makes the SQL statement always true. So you don't have to worry about putting in a correct password. And this is a kind of typical SQL injection attack. Stealth commanding, this is where a lot of our apps we build need to run something in the operating system. Maybe it's a third-party toolkit. Maybe it's a command line, ls at the command line to get a list of the directory. Maybe it's creating a directory. Lots of different things we could do. And stealth commanding is the act of sort of hijacking that and then running something nefarious, right? So in this case, put in the command you would like us to run man for. So ls, right? Okay, here's the manual for ls. So it's a nice little utility web app, right? Well, they just put ls, semicolon rm-rf, right? And so now it's not just running ls command, it's removing all the files in your directory, right? Not so good. So that's stealth commanding. Cross-site scripting. So this is where they're using a parameter you're taking to inject either some HTML that you don't want to see or some JavaScript that you don't want to see. And funny story on this, I worked for a really large company back in the day, and we built this app. It was very high profile, and it was a read-only app. So we thought, wow, we don't really have to worry about cross-site scripting, right? It's read-only. They can't get any data into our system that's bad. They can't steal any data. It's literally just a read-only system. Well, the hackers injected different images into our screen along with our corporate brand and took pictures of it. And these images were, not nice. And so they posted all these internet images out on, Reddit and other places. And so it was a big embarrassment, right? So even though it wasn't a data leak, even though it wasn't a data attack, or they couldn't really do anything to our system, but they hurt our reputation, right? So you got to think of everything when it comes to security, not just theft, but also reputation, right? So what's our secret? Really, it's practicing output encoding. And so the output, when you're doing SQL, the easy way to encode here is to not use dynamic SQL, but to use some sort of prepared statements or static statements where you're binding in the variable. So in this case, we're binding in the user and password variable. This is a Java prepared statement, and it's saying, hey, if they pass something else in here that just doesn't belong in that variable, the binding will barf, right? So it won't even run the query. You can do the same thing in Ruby and Python, and pretty much every other language has a sort of dynamic version where you're adding everything together to build a SQL statement, and a static version where you're binding in variables. So always use bind variables. Also, escape meta characters from HTML to make it safe. If somebody's passing in HTML and you're regurgitating it back into a page, make sure you escape it. It'll look nice in the HTML, but it won't be rendered HTML, right? So in Ruby on Rails, there's a utility called HTML escape, and that sort of does this for you. It basically takes out all the dangerous HTML element markers and replaces them with benign ones. For stealth commanding, this is a hard one. In fact, we spent a lot of time on one of our apps figuring out how to really, really lock this down, and it's tough. One of the easy things is don't just take a string and jam it into the system exec call or the exec call or wherever it is, but hard code the command or have a hash list of commands and only inject parameters. So in the first case here, I would build this string with, copy this file and, to this place and put in this user and password. In the second one, the first is the command and the second is all the parameters to pass to the command. If I passed another command into that API call, it would barf. It doesn't expect another command. There's no way to daisy chain or hijack or whatever. Still not completely safe here. We should make sure we're validating the user and the IP there that would be bound in there that would and make sure that those are indeed safe. And so there's no one-off answer to solve all problems here. It's each situation has to be looked at individually. Any questions on output encoding? You guys still awake? Okay. Threat 5, theft and manipulation of transient data or even data, not transient, at rest. So a lot of different protocols in the world are communicated in plain text, unfortunately, even still today. Some are out there wide open on the internet. Some are behind a firewall. And it really is no excuse. Every single communication should be encrypted and secure, and critical data should be stored at rest. Types of attacks here, man in the middle, CSS, brute force, talked about those a little bit. So the secret here is really, oops, sorry, went one page too far. Use cryptography to store data. For passwords, use a one-way hash. Don't encrypt passwords, hash them. I don't know how many of you have had an email recently from some of the bigger online applications that, hey, sorry, your password might have been compromised. That was because they were storing the passwords either in plain text or they were encrypting them, and hackers got into their systems and stole your password. If you hashed your password, they wouldn't be able to steal your password. So hash, for those of you not familiar with hashing, hashing is a one-way algorithm. So you take that password and you turn it into this set of bytes. And when they come back in and they put their password in, you use the same hashing algorithm, the same salt, and it can just compare the bytes. But we have no way to know what the actual password is. So it's a much better option when you're using passwords. The other issue is checking your crypto library. Unfortunately, computers are getting more and more powerful every day, and so algorithms that were great a year ago, 5 years ago, 10 years ago are no longer sound. They're no longer safe. They're easily hackable with modern compute power. So, a lot of us have used RSA, DSA, DES, MD5, SHA-1, and those are not okay to use today. So you got to look and check. And if you build an app and it's a year old, 3 years old, 5 years old, you should be looking at what type of crypto you're using and making sure you're keeping it up to date with the latest. Once quantum computing's out there, we're all in big trouble. We're going to have to implement new new algorithms to keep those from being cracked quickly. Oh my goodness. All right. Threat 6, exploiters of broken authentication. So almost every app we build here at Solution Street has some sort of authentication. Authentication is, logging in. Who are you? What are your credentials? And and then your authorization we'll talk about in a minute is like what you can do. So different attacks here: man in the middle, replay, brute force, dictionary. We've had, phishing is the newer thing, not new, but we've all gotten emails that said our PayPal account is locked, or we need to reset our password or something like that. And those are the hackers out there trying to, steal your data, typically through man in the middle attacks. So they're having you come to their site that looks like PayPal or whatever site you're supposedly going to, and they're recording all your data. Maybe they're sending it on to the real one and getting back the real page to show you a login so that you don't notice you were hacked. Or maybe they're just giving you an error message saying that's not the correct password, but they know it's the correct password, right? So the secret here is use a proper authentication model. All modern frameworks, Rails, Django, .NET, Java Spring, Symfony, have a built-in or a pluggable authentication model or framework. Use one of them. If you're going to roll your own, really make sure you know what you're doing, because there's a lot of things that could go wrong. If you're doing it your first time, you may not, consider. Most of these frameworks have been hit pretty hard by a lot of different people and tested, and so they're going to be a little bit more secure than something that you're going to try to craft on your own. Use the model to sort of, and the approach to make sure you're enforcing authentication. So again, using Rails as an example, every controller, which is an access point to the system, you can have a before filter or before action to authenticate somebody or authorize them. Use code reviews, pull requests to ensure that all your points are protected. So, it's easy enough. Anybody could write a new access point to your server, whether it's a function or a controller. And if they don't protect it, now that's a way in and may have access to, any sort of data. So, sorry about that. And then on the testing side, really it's important to check all the pages that, require authentication and make sure that you can't get to them. So log in, go to that page, bookmark it, log out, go back to that page. If you can get there, then that's a problem, right? So that needs to be tested constantly, because something that worked well, had good authentication, could break, and then some things may never have had it. The other thing that's important here is following NIST best practices for passwords. Those were updated recently in the last couple of years. They're a lot more reasonable, but definitely we try on every app to make sure we're following all these. I won't go through them all, but they have to do with the size and length and the amount of resets and all that good stuff. When possible, add multi-factor authentication. Make sure it's securely enrolled. A lot of people have seen implement multi-factor or biometric, and the implementations the enrollments are not secure, so they're kind of useless, because anybody could go and roll through it and then say, oh, here's Joel's second factor, and now I can be him, right? The other thing that's important, if you're using an ORM, object relational tool, make sure you're scoping everything by the authenticated user. So every call to gather data should start with user dot, right, or the equivalent in your ORM. Don't call, get me all the accounts and then filter it on the user ID. Start with the actual user, which will filter everything automatically for you. So leverage that ORM to sort of protect you from messing up. All right, threat 7, exploiting broken authorization or access control. So access control equals authorization, and this kind of goes hand in hand with authentication. So am I logged in? And now can I see stuff that I shouldn't be seeing? Going back to our parameter injection, can I see somebody's bank account that I shouldn't? Can I see some files on the server that I shouldn't? Can I get administrative access that I shouldn't? having a hard time with slide control today. My thing is either doing 2 pages or 1 page at a time. So again, the secret here is really enforcing proper authorization. All frameworks have something just like on the authentication side. On the authorization side, they have some sort of pluggable model or framework. They usually have a declarative option, a programmatic option, and a combination of the two. We usually recommend a combination of the two. So here are a few examples on the Java side. Declarative approach could be with the web XML and setting up, roles and the URL patterns. Pragmatic approach could be, asking if the user is in the role. And then the annotation on the right there could be, declare role manager for this class, right? So those are some examples on the Java side. I definitely know Ruby on Rails has a couple options there with like can that you can do it on their side, similar type stuff. Okay, threat 8, exploit poor session management. So when you're talking to a web app server, the thing that knows you're logged in is the session, and the way that's implemented is through a cookie on the client side, and then something on the server side that can decipher that cookie and decide, hey, this is Joel's session and he's logged in. Sometimes it's kept in memory, sometimes it's kept in a database, sometimes it's just derived on the fly. If you can hack this session, then you can become that person and do anything they could do, right? So steal their identity, access their resources. So the secret here is really just following the best practice. Ensure all your sessions are created using HTTPS. This is pretty common these days. Most pages are HTTPS. Not too many sites out there that are not anymore. Making sure the session identifier is random and unpredictable. Again, using a framework here whenever possible. Most modern frameworks do this properly for you these days. Where we get into trouble is when we're rolling our own, API or our own little mini framework, and we're not thinking about all the best practices around here. Invalidating our sessions, logging out, timing out, not letting them keep around forever. Don't store sensitive info in the cookies. If you have to store something in there, make sure it's encrypted, but really try to store as little as possible on the client side in the cookies. All right. Threat 9, denial of service attacks. So in this case, really, hackers are hitting your site and they're slowing your servers down or making them unusable by your legitimate users, and just causing trouble. This is a big problem these days because there's so many owned computers out there that hackers can take control of, so they can do distributed attacks, hit you from everywhere. There's so much bandwidth, mobile phones have so much power, so it's very easy to get hacked by nefarious hackers. It's also easy to get attacked by your own users, right? So the secret here is really limiting the resources that a user can have access to. So if they're not authenticated, don't let them hit some high resource page. Make sure they're authenticated first. Train your existing users to be patient. We've had several apps where the user hits the click button 9 times in like 3 seconds. You're like, how do you have that much dexterity to hit that submit button that many times? And then the server goes off and processes it 9 times. So train them, provide visual cues, give them a please wait button, give them the warning. It says if you hit this multiple times, you're going to get charged multiple times. That always helps. If it's a big heavyweight task, offload it, make it asynchronous. That way, if somebody comes back and asks for it again, you can just check, am I already doing this? Am I generating this giant 72-page report already? Oh, yes. So let's just ignore that second, third, fourth, and fifth request. We'll do it once and give it back to them when it's done. Disabling buttons after clicking, that helps. Checking your logging. If you're getting hit by attackers and you're logging every time, you can generate tons of garbage. There's one of the apps we get where we send ourselves email messages every time an exception happens in prod. Well, a lot of these times they're just hackers hitting our system and they're triggering these, so they're wasting all this bandwidth, space, email, logs, everything. So try to keep the garbage down when you know it's just a hacker coming in. Cache when possible, obviously, that will help when you're under heavy load. Last but not least, the last threat is really exploiting the weakest link. And a lot of systems, a lot of applications, there's a gap between development, between DevOps, between sysadmins, network admins, security admins. They're not all communicating as well as they should be. They're not sure whose roles and responsibilities they are to do what, especially in the cloud world where services are more dynamic and more codified. There's much more of an opportunity for a gap, for a misconfig, for something not to be updated, right? So typical issues in this world are misconfiguration, outdated operating system, language, framework, library, default accounts, insecure passwords, remote administration, all that good stuff. So the secret here is lock down your servers and do penetration testing. So really, before you're going to go live on any new production app, or anytime you're doing major changes, really go through and make sure only the stuff that's running as should be. Make sure there's no default passwords. Make sure everything is locked down. In a perfect world, you're not allowing direct access to any kind of VM or container. You have to go through some sort of intermediate step. Protected by an extra layer of protection. You're auditing, using strong passwords everywhere. Then we talked about this penetration testing. So anytime you're doing a major release, that should get done, and not just once, but repetitively, yearly. Our partner that we use for hosting, they sort of run their own penetration test all the time, and then we have a kind of partner vendor that we've used a few times. So if the customer doesn't already have this is something SolutionTree can work with them to provide. And then last but not least, actually the most important, is really creating a technical roadmap and keeping everything up to date. Keep your tech debt under control, upgrade your operating system, upgrade your programming languages, your services, your frameworks, your libraries. That's going to be where a lot of the bad hackers get in. All right. Deep breath. Any questions on the 10 threats and the secrets in addressing those threats? Did I miss anything that's obvious? Cool. So I skipped the slide at the beginning. It's a good time to come back and talk about it. When we're talking about application security or any kind of security, there's really two key sort of concepts that I always think about and I always talk about. The first one is, crunchy to the core, right? So the idea here is, if you have a castle and you have an outer moat, and then your castle inside there is completely unprotected, all they have to do is get across the moat and take over your castle, right? Whereas if you have a castle with a wall, a moat, another wall, a bridge, I think Jeff's, Helm's Deep maybe suggested, guard towers, all sorts of layers, that's what we call crunchy to the core. So you get in the front door, you're still in trouble. You get in the second door, you're still in trouble. So really thinking about security as making it hard on the hackers at every step of the way, right? So that's the first concept. And then the second concept is transparency and discussion. Everyone's terrified of being hacked. We will all get hacked in our careers. I've been hacked multiple times, both personally and at work. It's embarrassing, but hiding it is not the best option. Being transparent, open up the discussion, talking about what happened, talking about how we can prevent it again, talking about how we could possibly be hacked. That's another key point. So really, crunchy to the core, being transparent and open and discussing it, those are the two things that are the most important, that sort of underlie all these different approaches to building secure software. All right, so let's talk about process. So we've probably all been on a project like this. We call this the 7 steps of doom. You build your software without security, get hacked, you fix those, you wait, you find out you got hacked again, you fix those, you wait, you find out you get hacked again. So we don't want to do this, right? So we want to do the secure application lifecycle, right? So secure design, secure development, secure testing, secure deployment, secure operations, auditing. We're always thinking about security in every step of the process. So we're really thinking everything we do, every step of the way, and we're building security into sort of our daily, our daily themes, our daily to-dos. We should definitely be having application security reviews for every major component, for every major new system, service, and these are sort of 5 things we feel like should be in every review. Every company may have their own application security review process. That's fine. There's no one right answer. But these are sort of the 5 things we feel like should be in every one of them, which is first, what are our assets and how are we protecting them? What is our security architecture? What are our vulnerabilities? Document them. What are our mitigations to those vulnerabilities? And are they acceptable? And then what is our risk level, right? So, the analogy I like to give here is if you think about a bank, banks are inherently insecure on purpose, right? So anybody can come in and rob a bank. It's a fact. It happens all the time. And the reason that they're that way is because if they were to really secure them the way they, to make it very difficult to rob a bank, they would have man traps. They would have you go through a metal detector. They'd have you go through a strip search. They'd have you, many, many layers of security there. And that's not good for business. Like, no one would go to a bank if they had to go through all that, right? So banks made a conscious decision, a trade-off of saying, how can we make it reasonably secure but still hospitable to our end users? So we're going to have vaults. We're going to have silent alarms. We're going to have, cameras. We're going to have security guards, sometimes unarmed because we don't want to scare our customers. And we're going to have ink packets we throw in the bag if somebody robs us, right? So we're going to ruin the money. So they kind of balancing out that sort of risk reward. And we have to do that on everything we build. We can't make every app hack-proof 100%. We have to make them reasonably hard to hack, but reasonably usable to our end users. Does that make sense? Okay. So I want to summarize our process. We have to understand application security. We should incorporate it into our process. We should do a review for each release, each component, each service. We should really try to automate as much of our security, our testing, our penetration testing, anything we can just to make sure it's happening all the time. And we should leverage frameworks whenever possible to follow best practices. So there's the summary, the 10 secrets. We talked about process. Anybody have any questions? I'm going to stop talking for a second.
Joel, you mentioned pen testing your server. So are there any tools that we can use to do that? I mean, obviously,